Hey guys, back to new video. This video is not about any kind of data structures, any kind of algorithms, any kind of competitive stuff, but this video is about how to approach a problem so that you can solve it. Whether it might be a competitive coding question or it might be a practice question, anything, you need to solve that, right? What is the first approach you need to do over that problem so that you can get a solution? In this video, I'll explain all the approaches that I usually do. It's not a set, it's not a protocol, it's not a rule. You should follow those things only. That's what I follow to solve competitive coding questions or some practice questions. Okay, first thing, read the question. Read the question once. Please just watch all the videos, all the competitive coding questions I have done, so that you can get to know what a practice question is, what a competitive coding question is, then later hop on to this video. So first read the question. Read and understand. Read and understand the question, okay? Then look at the input and output parameters. Like what and all the inputs the user is giving or the computer is giving, in what way and in what way you need to return the result to the computer so that your result get verified. That's most important. If the computer wants a return type in list and you return as an integer, it won't count. Even if it is right answer, it won't count. That's the main problem while practicing these kind of questions. Okay, next step is constraints. What are constraints? In each and every practice problem or competitive coding problem, you will be having a block called as constraints. Like it will mention the number of test cases, the range of the length of the list or arrays if it includes an array, and the numbers range which are going to be in the array. That's a constraint. So you need to have a quite bit of view on that so that you could get a big picture of the problem from there itself. Whether if the test cases contains around 100 to 200 test cases and if the length of the array is too big, then you need an optimization technique for that. Otherwise it will be an easy problem. If it is an easy problem, then just solve it in a brute force manner. It will work. Trust me, the brute force solution will work if the length of the array is too small or the numbers range in the array is too small. If it is bigger, then you need to go for optimization techniques or you have to use some algorithms to solve those problems. Okay, now the fourth thing is, after doing these three things, you need to think of which data structure to use. Okay, to solve that question, which data structure to use, whether you want to use dictionaries, whether you want to use tags, whether you want to use queue, you need to analyze those things, then only you can code. Otherwise, if you just simply jump over to the editor and you just keep on coding, you won't get the solution. You will be stuck some point. Okay, pick the data structures. Fifth point is, think of any algorithm you know. Like through any algorithm you can solve that problem easily. Just think of it, because you will be coming through a lot of algorithms in your life, in your career, right? Just think of applying any one of the algorithm which suits the best for it, so that it can optimize the time or else it can optimize the memory space. Sixth is DP. What is DP? DP is really a nice concept known as dynamic programming. You can solve a problem in very less time actually compared to any other brute force or other algorithms by using DP. DP is nothing but a hash map. There is no rocket science in DP, but you need to be good at basic mathematics while using DP. Because DP is about storing the results. It is about storing the pre-computed results and using the same results if using the same results in the later part of the problems. Like you need to calculate factorial, okay? If you need to calculate factorial, if you have the value of factorial value of 3, you can store it, and you need not calculate the factorial of 3 again if any problem or in the same problem you get to calculate the factorial of 3. That's what dynamic programming is. That's a huge concept. Let me just keep it aside. There are many other algorithms known as greedy algorithms. Even that's fine, because even from the greedy algorithms you can get many solutions in time optimized as well as space optimized. I don't know about space optimized, time will be optimized, and you'll get correct solutions. That's what the thing is. You won't get wrong solutions using greedy. And dynamic programming, the one myth about dynamic programming is it need not always optimize your time. Because I know one such problem in which dynamic programming is worst. That's about trees, I think. Yeah, it's about a knapsack problem. You might be heard of knapsack problem, right? 0-1 knapsack. Not just a regular knapsack. Regular knapsack problem can be solved through greedy algorithm, but 0-1 knapsack problem cannot be solved in greedy approach. I'll explain you the 0-1 knapsack problem actually in my upcoming videos when I come into algorithm part of this channel. There you will be having a tree. I haven't explained you about the tree, right? Okay, now I'll just stop this video right over here. In the next video I'll explain you about trees and binary trees, binary search trees, and there is something called as trie. Trie is nothing but a tree itself, but with more than 2 branches. That's it. That is nothing but a graph actually. And graphs, algorithms of graphs, algorithms of trees, algorithms of binary search trees, heaps, AVL trees, priority queues. Those are somewhat advanced data structures which I will be explaining surely in this channel. Just stay tuned. Please watch my videos. Just hit the like button, share my channel, and subscribe my channel. In this pandemic, be safe, be locked from the outside world, stay in a safe place, and keep on reading. Thank you.